hello everyone, I'm really excited to be here. It's my first time at jeeconf. I'm Stéphane, I'm working on the Spring Boot team, the Spring Framework team, and a little service you may have used if you're a Spring user called start.spring.io. So I'm working on that. So before we start, I already know, unless you were hiding during the keynote and you have a different profile, but I'm not sure that happened. So I know you're already all Java developers, more or less. What I want to know now is who's not using Spring Boot? Not. Wow, that's 5%, not even 5%. Okay, so Java developers and Spring Boot users, that's awesome. Who's using Spring Boot 2 already or later? Like everyone, almost. That's good, because remember, for those who didn't raise your hand, whether you were using 1.5 or you were lazy, it doesn't really matter. 1.5 will be end of life this summer, so we won't provide any more security patches to it. So make sure to upgrade. There's a migration guide and everything. Right, so I have a few slides. Don't worry, it's not going to be a slide-based presentation. It's going to be mostly live coding, and hopefully you'll get a chance to look at the code after the talk if you want to, because it's on GitHub already. So I just want to give you a few, basically put the scene for the demo application we are going to work on today. This is your choices as of Spring Boot 2. I'm sure you know that. So if you decide to build a web application, you can either, on the right-hand side, build it with the servlet stack, with a servlet container and Spring MVC, and one thread per request, everything basically that you know. If you've built a web application with Spring, or if you've built a web application with Java, really, in the past, that's probably what you've been using somehow. There's a new option as of Spring Boot 2 with the reactive stack, where you can decide to go full non-blocking with reactive streams driver for all the things that you need to. So reactive streams driver for your database, reactive streams driver if you need to access whatever service to make sure that everything you do is non-blocking. And then use an event loop to dispatch the load. And you can run those apps on Netty, or actually with Spring webflags, there is also adapter for Tomcat, Undertow, and Jetty if you decided to do so. So these are the two choices that you can have if you build a web application. And we've been telling you the past 2 years about those two choices and the fact that Spring MVC is not going anywhere, that we are not going to ask you to rewrite your app using the reactive paradigm. So if you have an app, it's using Spring MVC, it's deployed on a servlet container, and you're happy with it, fine, right? No need to rewrite this for the sake of spending time rewriting it. So these are the two choices that you can make, and we've been telling you that the past 2 years. And what I want to do today is to tell you that there's a third choice if you want. And this is really about how you can be more efficient with your existing application. So potentially there's a higher chance that you have a Spring MVC in this case application. And now how you can use some of the reactive features within your Spring MVC application. So this is what we do. The Spring team, we really try to make sure you have as many options as possible. So reactive stack, servlet stack, or servlet stack with some reactive features on the back end. So we will be working on an app, and so this is start.spring.io, and every time that you go there, we actually record your choices. So we record the build system you've used, the dependency you've used. So we know how many projects are generated per day, that kind of stuff. And there's not only the web UI to generate a project, you can also generate a project from your ID. If you don't know that, check out your favorite ID, there's support for that. You can do it on the command line. So if you have curl installed on your machine, try curl start.spring.io. You'll see something will happen and tell you how to get started. If you prefer HTTP PI, there's support for that too. There's also support for the Spring Init CLI. So what we are going to do today is we will build a dashboard application that, for the purpose of the sample here, and show you how you can be more efficient, has to contact 3 different services. So there is the project statistics I was talking about. There is a event service that tells you what happened during the timeline that you want to see statistics for. And there is also an IP lookup service that gives you the IPs that have been using the service the most. So what we want to do is just see if there's someone abusing the service, right? So it's a demo, and let's assume that those 3 services are running somewhere, and these are third-party services. There's nothing you can do about the API. You just have to comply with the API. And last thing is what we don't want to show the IP, because it's not very interesting for a human seeing an IP, so we want to show the reverse lookup, so the name of the server. So we have a reverse lookup service that we can call, and unfortunately, that service only accepts 1 IP at a time, so we have to call it every time we want to resolve an IP. Right. Okay, so let me maybe shut that down, because I don't need it. I have an app, it's running on my machine. Quickly show you what it does. So it does something like this. Not very interesting, right? But it's just to have some base to start from. So there is this nice graph, some events, some top IPs over there, and a very smart resolution algorithm, as you can see. As you can see, very, very smart. And just to give some perspective, let's have a look to the kind of data that we have. So all 3 services, for the purpose of the demo, they're running on port 8081. That if you check out the project, you can basically run 2 apps. One app on 8081 that will give you the 3 services I was talking about, and one app on port 8080 that represents the UI, so the dashboard application. So you get this, some statistics. You can also get some events, right? If you give it with a timeline, and you can also ask it for the top IPs. And this is auto-generated data, right? It doesn't matter what the data actually means in this case. Let's have a look to how it works concretely and how we can make it more efficient. So I have here a client with the RestTemplate. I'm using RestTemplate Builder. If you don't know about that, and you are using the RestTemplate, it's very convenient. It's a class that Spring Boot will auto-configure for you. You can inject that in your own component, and it will basically pre-configure the RestTemplate. So if you have a Jackson serialization strategy in place, it will detect that and apply it. If you want to do some extra logging or extra metrics or whatever, it will take that into account. And the access to the 3 services, as you can see, is very, very easy. These are the 3 endpoints as I just showed you on the command line. And the core of this service is this. So I'm basically using the client to fetch the stats, then the events, then the top IPs. And as I was mentioning, what I want is really the reverse lookup description. And for that, I'm calling a reverse lookup service. Okay? As you can see in this version, we are trying to be a bit smart by using a parallel stream, trying to invoke those reverse lookup in parallel if we can. But every other blocking code there, it's basically on the same thread. So it's like, get me the statistics, wait, get me the events, wait, get me the top IPs, wait, etc., etc. So we want to make that a bit smarter, and that's the first step to introduce some of the reactive features in our application. So let's start. So to do that, I can actually add the webflag starter in my application. And when I do this, Spring Boot will consider, because you have the web starter and the web starter takes precedence for backward compatible reason, it will start an app, an MVC app, regular traditional MVC app, and it will consider you using the webflag starter for using reactive features on the backend, right? So that's what we are going to do. Let me restart this app first because I've changed the class path. I want to make that a bit smarter, and the first thing I want to do is, rather than using the RestTemplate, which has a blocking API as its core, I want to use the web client. The web client, if you don't know about it, new in Spring Boot 2 and Spring Framework 5, it's a new API that we've redesigned from the ground up to access HTTP services, and we highly recommend to use it, as we are considering now to deprecate the RestTemplate at some point. We want also to make sure that you can upgrade to this new paradigm without having to, rewrite everything. So remember, I was telling you about this RestTemplate builder. There is a similar concept for the web client. So there's a web client builder you can inject that's going to be auto-configured by Spring Boot. So let's use this new API. It's a bit different, but not that different. So I'm going to do this, and the key thing is the web client basically is going to return you a publisher. It's not going to return you the data. It's going to return you something that can provide the data once something is expressing an interest. And as you probably know, if you've been following at least one reactive session with Spring, Spring uses Project Reactor as the reactive streams implementation. And there are two types to consider there, two types of publisher. One is mono, where you can have 1 or 0 element being published, and the other one is flux, and flux is for a number of elements, potentially infinite, right? So in this case, what I want to know is, what I want to get is, I want to get a single signal with the generation statistics object. So I'm going to get a JSON, the first JSON I've shown you on the command line, parse that, and when the parsing is done and I have the object, I want a single signal with the object. So I'm going to do body to mono generation statistics dot class, and of course that returns a mono. Okay. If I want to return a list, you can see here I have a list of events. That's the other one. That's facts. And for that same thing, I can do get. The parameters, retrieve body to flux. This one is a little bit different. I should probably do get URI. Probably going to work better. This one is a little bit different because we are expressing a flag. So we are expressing the fact that potentially I'm going to receive a collection of objects, and I can already send those objects while I'm parsing them, right? So I'm getting the JSON results from the remote server. I'm starting to deserialize the content, and once I have an element, I can already, if someone is interested, if someone is ready to consume the data, I can already send that right away without having to wait to deserialize the complete collection. So there's one more method to do, but I'm bored already, so let's check out that. No, that's not what I meant to do. Check out revision. There we go. So let's go back in my app. Probably I have to log in now. Yes, because I've restarted. There we go. Okay, my app is still working. Let's connect maybe there. It's still working. So let's have a look to what I've changed. So this is not really very smart, right? Rather than, I mean, this is exactly as what you had before. We have all this nice machinery where we can potentially send things in parallel and optimize access to the remote service. But what we do now is what we were doing with the RestTemplate. So this is really the first iteration where I'm using the new API, but I'm not using any benefit of the new API. So I'm calling block in every step in the way. So you can now clearly see in the API that those calls potentially have some latency involved. And of course, we want to fix that. So let's fix it. And the way to fix it is to improve the definition of our pipeline, right? Rather than having just the HTTP calls returning a publisher, we want to go one level up and actually returning a publisher of the stats container. So that's the return type of this method. How can I do that? It's actually quite easy. So rather than blocking, what I'm going to do is I'm going to keep the publisher definition for those things. So remember, events was a flux of events, but I'm actually not interested by that, okay? I don't want to get an event every time. I don't want to get an on next event on the publisher every time there's an event, because I'm not interested by streaming events or reacting to events. What I'm interested in is give me the list once you have the list, right? I don't care about being smart about each individual events, because what I need in the end is the list. And there's an operator for that in Reactor called correctlist. So correctlist on a flux, what's it's going to do, it's going to buffer the events as they come. And once the publisher completes, you basically have the full list in the buffer, and you can send a single event with the list. So mono list of events is basically one element, and the target type is the list, which is pretty obvious from the signature here. The last one that we need is this guy. Same thing, not interested by every single top IPs. What I want to know is the result. So I'm going to, I meant to copy that. There we go. Let's call that top clients. So find top clients from date to date. And I want my method to be quite natural, so I'm going to use correctlist here so that the actual return type is a flux. And it's a flux of this type. Right. So this method there, what it needs to do, it needs to contact the third service, give me all the IPs, and then it needs to basically massage the data and map that to a reverse lookup descriptor. So how can I do that? Basically, that you already have the blocking code here. So let's make that a bit smarter. Right. So this is going to return me a flux of IPs description. And what I want to do is I want to map that to the reverse lookup counterpart, which is this one. Let's call that description. There we go. So there's one difference. There's one major difference compared to the code above. Remember, I told you about a flux and the fact that you get data and you can already react to data as it comes. So this potentially, if there are enough resources on the server, you'll start deserialize IPs, and as soon as you have one, if there is enough resources on the server, you can already issue an HTTP call right away to get the reverse lookup. So you don't have to wait for the whole list to be deserialized. You can already post-process the data as it comes. So that's one of the advantages. The other advantage, even though the list here is not large, you're not actually buffering the list, right? You don't care about the IPs. All you need is you need a value to actually call something else, but you don't need the full list. It doesn't matter. So that's a way for you also to optimize if you have a large collection of data. So I'm going to remove all of this because I don't need them. And let's have a look now to our method here. So I have my 3 description and the builder. But remember, this is not doing anything yet. I just have 3 publishers. I need to basically tell Reactor, the reactive streams implementation, do something with that in the most efficient manner, and then call me when you have the data. And there's an operator for that called zip. So let's use it. So zip, you basically give it a bunch of sources, and it will subscribe to those sources, and it will give you a callback once it has the data. But the interesting thing is that the way the 3 elements here in my method call are being retrieved, Reactor takes care of that for me. I don't have to, if I want, I don't need to think about thread pool and fork join and what happens if there's a timeout. I don't need to do any of that. I'm just asking, these are the 3 things I'm interested in, just figure out how to get it. And the callback gives me a tuple, so let's move the data over here. And basically the tuple is named like this, right? Because I have 3 elements here, so I get a tuple with 3 access and tuple.get t3. All right. And obviously that's returning a mono. There you go. Okay? So there is overridden method for if you have 4 methods, 5 methods, 6 methods. I don't know where they stopped. They stopped eventually at some point, so that you don't have a method with like 25 parameters, which would be a smell anyway. But this is one optimization you can have, right? So now you're basically telling Reactor, I need those 3 things. Just get them from me, and once you have them, just call me. If we try to run this app, it won't work anymore because I'm filling the model here in my controller. So this is basically the URI of the main endpoint where we issue those calls. We get the container, we put the container in the model, we ask a view to render, I think it's a time leaf view if I remember correctly. So we ask time leaf, please render the view, here is the model, you know, the usual stuff. But right now, this method is returning a publisher. So something should, you know, ask for the data. And you have one block here that's basically triggering all the chain. So this call, when it's invoked, it's basically expressing, I want the data, so please make sure I get the data. So it's a subscribe and block indefinitely. Right. So there's my app. Still working as before, not really something very interesting to see, but it's going to become more interesting with the next demo. But now those calls are happening in parallel because my server is doing nothing, right? It's my server, I'm the only user. I have a thread pool for the HTTP client, so I know that the 3 first calls are done in parallel because there are enough resources. And while I'm deserializing the IP, I'm already issuing other calls to get the result value. So my test is failing now because this assertion is no longer true. I'm not returning a container, but a mono of a container. So I can do this to fix it. So mono.just is just going to return you a mono with the hard-coded value. It's very useful in tests. Just very easily create a mono. It also gives me a chance to quickly show you, if you haven't seen it yet, the new testing support in Spring Boot 2, since most of you are Spring Boot 2 users, I'm guessing you already have seen that. So I'm actually writing a test for a controller, setting security over here because I'm using Web MVC test. The mock MVC thing is already auto-configured for me. My controller, which is this one, require a stat service. And it's not going to be created, actually. So with slice test, we only create the bare minimum context. So in this case, we only configure the MVC infrastructure and this, and nothing else. So I'm basically mocking the required dependency. And then I can write that. And it's very easy to write those tests that way. OK, so let's make sure something bad happens. On my backend, I mean the generator, I have a service. I have a service that I can fake latency on something. And right now, it doesn't do anything because the ratio is at 0%. But the latency is between 200 milliseconds and 8 seconds. So basically, what it's going to do for a matching request, it's going to slow down between 200 milliseconds and 8 seconds randomly. Okay, so it's chaos engineering. And this endpoint, I can change the ratio. So now I've changed the ratio to 80%. So let's try again. You can see it spinning on the in the tab, and eventually it will show up. So, right, something. Let's pretend we don't know any of that, right? So that's the next part of the demo is something is really slow now, and I need to figure out why. And I'm going to show you how you can have some tools to help you with this. So first of all, let's see if my app is healthy. And it is, but it's not telling me much. So I'm going to configure the application to give a bit more detail. So show details, when authorized, sounds good. I'm using DevTools, by the way, which makes sure that my application restarts automatically and my browser restarts automatically. So these are the details. I can see that I have a Earth indicator for the reverse lookup, but doesn't say much, and it's still slow. So we need to fix it, right? We need to do something. So Spring Boot 2, one of the new features in Spring Boot 2 is the integration with the Macrometer project. Who knows about the Macrometer project? Well, compared to those who are working with Spring Boot 2, that's really not a lot. It's like 20% tops. So Macrometer is a new initiative, and their tagline is, it's like SLF4J, but for metrics. So the purpose of the Macrometer project is to give you a base API that you can use to define metrics. So you can define custom metrics, you can set the value, increment the value, decrement the value, that kind of stuff. Any metric can have a number of tags, so you can tag a metric to give it a nature, if you will, and you can use those tags to filter data. So for instance, if you have a metric that represents the startup time of your application, you need to tell which application it is, or you need to tell on which host. So you basically need to identify where that value is coming from, and tags are a useful way to do this. Spring Boot by default, so if you have an app with Spring Boot 2 and the actuator, as it's the case now, you'll get a bunch of metrics being exported automatically. But you need, as a developer or as infrastructure maintainer or whatever, you need to basically tell where to deploy those metrics, and that's the second part of the Macrometer project. One part is the first part is the standard API, and the second part is they provide a bunch of registry implementations for all kinds of monitoring systems. So what I want to do for this application, I'm going to use Prometheus. So if I want to use Prometheus, all I need to do is, why am I? Oh, wow, okay, fine. Where am I now? That's not what I meant to do. Go away, dashboard. That's the thing I did. Wow, I'm stuck in a revision. Why? Okay, let me try this. Project view. Oh, wow. Project view, wow. Any IntelliJ expert helping me where to unstuck myself from here? Project. Oh, there you go. Wow. Okay. Well done, Stéphane. More coffee. Thank you. Right. So Prometheus registry. So if you do that, you're basically adding a implementation that will do whatever it takes to export the data to Prometheus. And I want to identify metrics from this application. So one way to do this is to add a tag, so a tag that will have the same value for every metrics. And I'm defining a tag called application, and I'm giving it a name, which is the name of my application here. Okay. So Prometheus is a bit special compared to any other monitoring systems, really. Most monitoring systems are push-based, so you give it some place and the implementation will push metrics to it. Prometheus is different in the sense that Prometheus basically calls your app. So it basically calls an endpoint and scrape the metrics, fetch the metrics from the application. So this is what you see here. I have a job named Spring. Every 5 seconds, it's calling this endpoint, and it does so for my dashboard app and my generator. We won't look at the metrics for the generator; it just happens to be there. So if you run Prometheus from that directory, it will look for a configuration file called prometheus.yaml, which is the file I've just shown you, and it will start scrapping every 5 seconds. And as you can see, it's complaining now at the bottom there, because it can't. And it can't because there is security in my app. You've seen me log in as admin. Right, so let's fix that. And of course, there's 2 ways to fix it. One way is to give Prometheus a token or access to that endpoint. Or you can be like me, doing a demo and being lazy and give it access. So that's what I'm going to do. Prometheus scrap endpoint, there we go. If you haven't seen that, it's also the new way in Spring Boot 2 to secure your application, making sure that you have all your configuration in one place. So if I go back to my browser, my application will restart. I need to log in because I've changed the class path. There we go. And my app is still slow. And Prometheus should stop complaining. Yeah, it did. Very nice. So now, with that new registry, what happens is that those metrics I was talking about that are automatically recorded for you, they are being exposed to Prometheus. So we can actually look at the Prometheus base interface to see what they look like. So it's 1990. And these are all the metrics that you can have on an app. Ignore the ones that are called Prometheus, because these are the metrics from Prometheus itself, but you have statistics about the JVM, the process. There's also some statistics about HTTP, so let's have a look to that. And let's in particular having a look to the one that's highlighted. You can see that it has a bunch of tags. You can find back the application initializer dashboard I was talking about. There is an instance tag that's added automatically. The Spring job is the one from the config. You can see it's a HTTP GET. That's a success with 200. And you can also see the path. So the path is that method where I added the block invocation to fill the model, right? And you can see that the max time is 7.8 seconds, which is very, very close to the 8 seconds max that we have for the latency endpoint. Of course, all that stuff is not very interesting. I mean, as an operator, you would probably want to see something a bit interesting, right? So there is also Grafana, which has an integration with Prometheus and a bunch of other data sources. So this is the kind of out-of-the-box experience you can get with Spring Boot and Micrometer. This dashboard is actually shared on the Grafana website. So if you search for it, you can have a custom Grafana instance in your environment and just add it. But yeah, that's still not helping us figuring out what's going on. So let's have a look to a bit more data. And I've built this dashboard with more information. So let me first select the right application. And there you go. Okay. So the top right graph is about HTTP calls that the server is invoking, right? So it's not the response time of the server. So if you call something on 8080, how much time it will take. It's really about what you do as a developer on the back end. So in the case of that demo today, it's calling those 3 services and calling the reverse lookup. You can see that everything is fine. It's quite fast, but there is the free reverse lookup. It's going completely nowhere, right? And now we know that the latency endpoint is actually impacting that service only. So the latency endpoint is simulating the fact that the free service may be unreliable. It may be very slow. It may be down, or you can have all kinds of problems with it because it's free. So what I wanted to show you now is how once you have this infrastructure in place, so with the reactive web client, how you can improve that definition to be more smart about it, and how you can let Reactor do the heavy lifting for you. This application also has a paying service. So every time you call it to do a reverse lookup, you have to pay something. And of course, you don't want to call it if there is a free alternative. If the free service works, just call the free service. But if the free service doesn't work, you really want to do something about it, right? So let's have a look to that. Let's go back to our stat service here. And the key is this method. Getting the IPs, and why I get the IPs calling the reverse lookup. We know that this one can be a problem, so let's actually change the definition of this one, and probably need to do that on the right thing. Let's add a timeout operator on it, okay? So as you can see, there's a bunch of things you can do on a publisher. In this case, this is a mono that does the reverse lookup. So let's say, for instance, duration of milliseconds, 500. Then you have to give it what you should do, what basically Reactor should do if that timeout is reached. And here I'm basically saying, oh yeah, okay, fine. If it lasts more than 500 milliseconds, give up and call the paying service. So let's have one more look to our app. Okay, so you can see it's much faster now. And if we look at the statistics, well, okay, I mean, the ratio is so different now that it's tiny, tiny, tiny. But let's wait a bit for it to complete. There we go. I can't see it. I have to wait a bit more. But you get the idea, right? The timeout operator has nothing to do with HTTP. It's really related to the publisher and subscriber infrastructure. So it's built upon that contract. So Reactor doesn't care about the fact it's HTTP or something else. It will try to subscribe to some elements, wrapping that subscription with the fact that if 5 milliseconds after asking for the data, it doesn't get the data, it's basically canceling the request. So it's saying, I'm no longer interested by this. So it's basically telling to the publisher that's returning the reverse lookup using the free service, I'm not interested by that anymore, just cancel. And it will subscribe to a different publisher, which is the one that's calling the paying service. Again, the fact that it's calling HTTP doesn't matter. But the interesting bit is when the timeout is reached and a cancel on the subscription is issued, so you're basically saying, I don't want that anymore, the implementation of the publisher, which knows about HTTP, will make sure to close the connection for you, do the resource cleanup and everything. There we go. So if we go back, we can see now that the max, because remember it's auto-generated, it's random, sorry. You can see that the max now is 349. As soon as you hit 500, we just give up and use the paying service. Something else also you could see is this graph. I was talking to you about tags. Tags is also a good way to show data, show the same data with different, let's say, filter. So this graph is telling you how much time the free service is called versus how much time the paying service is called. And we can do that because we use the URI. The URI is different, so the remote HTTP URI is different, and we can use that as a filter. All right, so I have like 5 minutes, and what I want to show you quickly is how you can get rid of this and make that an external property. So you all know about, as a Spring Boot users, you all know about this feature, right, where you can put some keys in the files or system properties or environment variables or whatever, and it will be picked up by Spring Boot and you can use it. What I want to show you now is how you can make that for your own keys. So let's create quickly a class called dashboard properties. And I'm short on time, so I'm just going to do a raw timeout here. Milliseconds, 500. And adding getters and setters to it. So I have an object, right? And what I want to do is I want to tell Spring Boot, can you bind, please, that object for me on a prefix called dashboard? And I also want it to make it a component so that I can inject that class somewhere else. And that's what I'm going to do here. I'm going to do create a timeout here, duration timeout. I can inject my dashboard properties. Properties, timeout, properties, timeout. And the interesting bit here is you as a consumer of this, it doesn't matter how it's being bound, right? It's an implementation detail. You're just using keys. And I'm going to do here this timeout. And let's use it to see if it works. So dashboard.timeout, let's say 100 milliseconds, right? Okay, that seems even faster. But one more interesting point, remember that the tolerance for the latency was between 200 milliseconds and 8 seconds. So since we're below it, basically the free service won't be invoked anymore because we are too greedy here. So let's have a look to what that means concretely. So we can see now that the costly service is used a lot and the free service is not used anymore. I have 2 minutes just to show you one more thing, is that yellow thing there saying that IntelliJ doesn't know about the property, right? It's really frustrating. So who knows that you actually can do the same thing as Spring Boot, you can get the same experience for your keys, who knows that? As always, 2.5%. Which is why I'm showing that at the end, so that I'm sure everybody at least remembers that. Let me very quickly show you how you can do that. So I'm adding a dependency to the project, and that dependency is an annotation processor. If you've used Project Lombok in the past, this is also an annotation processor. You know that you add annotations to your code, and it will magically generate getter, setter, constructor, and that stuff. So it's basically, while the code is being compiled, it has a chance to add extra bytecode to it. But you can also generate a file, a text file or a JSON file or whatever as part of this hook point. So what we do is we actually, this class is an annotation processor that will identify the configuration properties class in your project and generate a metadata file like this. So if I go back in my application, I have now auto-completion for it. I can see the default value as usual. You can see also that the duration is very well supported. And you get the usual stuff, right? So you can do something like this and basically have that there. Okay? So you can document your keys for your own team. I think it's quite interesting. Right, so there's two more demos I didn't have a chance to show you today. One is how you can create your own metric. So far you've seen only out-of-the-box metrics. So basically, HTTP client by sorry, if you're wondering where that came from, it's the WebClient builder that got injected in the service. So the WebClient builder knows about the fact actuator is in place, and there's a meter registry, so it will automatically add a filter that records metrics for you, so that if you create a web client yourself, you won't get any metrics. So the fact that we have those metrics is because you've used the web client builder. But what I've been showing so far is only out-of-the-box metrics, but you can, the same way you can add your custom keys, you can also add your custom metrics. And one metrics I wanted to show you is there is another problem with the free service, is that it has a rate limiting API. So if you call it too much, it will refuse to serve the request. And you can very easily create a metric that says how many operations are still available for this time frame. So if you look at the GitHub repo, you'll see a demo of that. And the other demo I wanted to show you is how you can go the extra mile and basically offer a live data of project generation. So basically having an infinite stream of event telling you how many projects were generated in the last 5 seconds, and basically stream that from the back end to the front end in a very efficient manner. So this is time where you pick up your phone if you're not on Twitter, but if you're on Twitter, I'll send that link later today, if I don't forget, as usual, but I will. And that's it for me. I hope you'll enjoy the second day. Thank you.